Okay, Unit 1 Final Exam Review Packet. First off, remember when you're dealing with inequalities, anytime you multiply or divide by a negative, you have to flip your symbol. So greater than will become less than equal will become greater than or equal. Also remember for graphing, open dot versus closed dot. Now, some people always like to have their variable on the left side, and that's fine. In this case, you would have to subtract 2x. Now when you do that, you're going to end up with negative x plus 8 is greater than or equal to negative 4. Then you subtract 8 from both sides, and you're going to get negative x is greater than or equal to negative 12. But then you have to deal with this negative 1 here in front. You got to divide by that. Once you divide, this symbol flips and becomes 12. All right. Now I'm going to erase that and do it again another way. Actually, I think you can do it without erasing it. Just do it here. So x plus 8 greater than or equal to 2x minus 4. If you are not hung up on having it on the left side, you could avoid the negative by subtracting the x here, which will give you 8 is greater than or equal to x minus 4. You add 4 to both sides, and you get 12 is greater than or equal to x. Now, what the problem is here is a lot of times, in this case, when the letter's on the right side, the one downside is people want to graph this way, but they want to graph this way if the x is on the left side. And you can't do that. That's not how it works. I don't know why this is not erasing. Very strange. Okay, so it does. I don't know why this is not right. Okay, so I'll put that back the way it was. X. Okay. So you have to think about that. So what I always remind you is always start reading from this. And if you read backwards, it says x is less than or equal to 12. So always read from your variable. And at that point, you just put a 12. It's going to be, this means a solid dot right there because it's less than or equal, and it's going to be going that direction. All right. Now, on number 2, first thing we need to do, we don't want to move anything yet because we want to simplify this side. This is negative 1x. Now, I don't have room to do it twice, but if you want to move the 7 over, you're going to subtract, and that will become negative 7x, negative 8x. But then you have to remember to flip. If you don't want to remember to flip, then you can move the negative 1x over, but in that case, you've got to remember that you have to move the 112 over. So it's actually 2 moves. Either way, you're going to have the same amount of moves. If you move the 7x over, you got to remember to flip the symbol. That's an extra move. If you move the negative 1x over, you have to move the 112. So it's really up to you how you want to do it. But I'm going to go with this. Negative 8x is greater than 112. Now at this point, as soon as I think about dividing by a negative, go ahead and flip that symbol. That's going to give me positive x is less than negative 14. Again, let's put negative 14 here. This is going to be an open dot going this way. Now, real quick, I did want to put, even though it didn't ask for it in the directions, just a reminder that it's never a bad idea to talk about interval notation. This is going out towards negative infinity and starting at 12 with a solid dot. This one is also going towards negative infinity and starting not quite at negative 14. So we use the parentheses because it's an open dot. Never hurts to talk about interval notation. All right, number 3. On this one, we need to distribute the negative sign. So that gives me negative 5 plus x greater than 3. I'm going to add 5 to both sides, which gives me x is greater than 8. Over here, I'm going to subtract 3x. I'm going to move and have positive x's. Just my decision. Doesn't really matter. 5 is greater than x plus 7. If I subtract 7, I'm going to get negative 2. And I'm going to get greater than x. But remember, that's really x is less than negative 2. Now, they're both open dots. Negative 2 is going to be left of the 8. They're both open dots. Greater than 8 is going towards positive infinity. Negative 2 is going towards, less than negative 2 is going towards negative infinity. Now, it does say in the instructions, also write in interval notation. So this is negative infinity up to, but not including the negative 2. And this is 8, not inclusive, going towards positive infinity. And that's going to be a union. All right, number 4. Now there's 2 ways to think about this. The quickest way is to think about all three sections. So minus 2, minus 2, minus 2. This gives me negative 3. I'm left with 1/3 x. Again, my symbols are here. And 7 minus 2 is 5. Now, to get rid of the 1/3, I need to multiply by 3, but I need to do that in all 3 columns. So that gives me negative 9 less than x less than 15. Now, some people prefer to do this twice, and that's fine. You can do one problem here, and then do another problem this way. You're going to end up doing the same thing, just a little bit more work, because like here you're going to minus 2, and here you're going to minus 2. So you do it 4 times instead of 3 times. Not a big deal, but you know, whatever you want to do. So this is minus 3 less than 1/3 x. And we're going to times by 3, and there's my negative 9 less than x. Over here, 1/3 x is less than 5 times 3 times 3. I get x is less than 15. Now remember, we got to read from the letters. So this is really x is greater than negative 9. So we put our negative 9 down. We put our 15 here. And they're both open dots. Now think about it. Greater than negative 9 is going this way. Less than 15 is going this way. We want that area right there. Just the in-between. We cut off the overlap on each side. And then interval notation is between negative 9 and positive 15, not inclusive because we have open dots. Okay, number 5, I'm just going to do this the 3-column way. If you prefer doing it twice, that's fine. So I'm going to add 5 in all 3 spots. 5 minus 2 is 3, that less than or equal. 3x is left, and then that's going to be 18, and it's going to be less than. Now I'm going to divide by 3 in all 3 columns. 1 less than or equal to x, or x is greater than or equal to 1, and x is also less than 6. So I'm going to have a 1. That's a horrible 1. Not much better. There's a 6. Now with the 1, I have an open dot. A closed dot. And with the 6, I have an open dot. And if you think about it, x is greater than 1, which is going to go that way. Less than 6 is going to go that way. I want the overlap. And then this is a little bit different. I got a bracket here and parentheses there. And that's interval notation for that problem. Okay, absolute value equation should always get 2. All right? Now, what we're going to do is we're going to bust this out and write it twice. If this is alone, and since this is alone, we're ready to go. 3x minus 4 is equal to 11. But we have to do a second one. And we just make the other side opposite. So I'm going to add 4 to both sides, and I get 3x equals 15. Divide by 3, x is 5. Over here, I'm going to get 3x is equal to negative 7. Then when I divide by 3, I get negative 7/3. And those are my 2 answers. Now over here, remember, think about this as just a basic equation like this. Go back to what you know from middle school. Substitute this with just an x. And just think about it this way. What would I do first? I would add 18. And that would give me 4x equals 24. 4 times something. This is my something. Divide by 4, x is equal to 6. So it's going to be similar. I'm going to add 18 first. Both sides. So I get 4 times my something, which is x plus 9 here, is equal to 24. Then when I divide by 4, my something is equal to 6. Now I'm going to bust it out. X plus 9 is equal to 6, and x plus 9 is equal to negative 6. Now I subtract 9, and I get negative 3, and I subtract 9, and I get negative 15. And those are my two answers. But just think about your your absolute value as a variable. Remember what to do. Same thing here. If I had x over 2 plus 4.5 equals 7, what would I get rid of first? I'd subtract the 4.5. Okay? And I'd get x over 2 is equal to 7 minus 4 is 3, so that's going to be 2.5. Now I would get rid of the 2. And I'd have x equals 5. Similar thing over here. I'm going to subtract 4.5, and I'm going to have my unknown, which in this case is my radical. Sorry, I keep saying radical. Absolute value divided by 2 is equal to 2.5. Now, to get rid of that 2, just like before, I'm going to multiply by 2. Now my radical, which was my unknown over there, is equal to 5. And I'm going to bust it up. X minus 2.5 is equal to 5, and x minus 2.5 is equal to negative 5. Which then I'm going to add 2.5 to both sides. I get 7.5, and I get negative 2.5. And there's my two answers. But remember, it's just like a middle school problem. You get rid of the addition and subtraction first, then you undo division or multiplication. All right, number 9. It's not by itself. We need this by itself. So we need to divide by negative 2. That gives me 3x plus 5, absolute value, equals negative 5. Now, some of you are going to want to bust this up and say it's equal to negative 5 and positive 5. But remember, we stop right here. Why? Because an absolute value alone cannot be equal to a negative number. Remember, this number, absolute value, equals the distance from 0. We don't measure distance in negative numbers. So therefore, we stop and we say no solution. Okay, now inequalities. Inequalities, you can have a negative number over there because it's not a set number. But we're still going to do the same thing. We need to get the radical, oh, there I go again, the absolute value by itself. So I'm going to divide, and I get the absolute value of 2x plus 4 is less than 10. Now, I'm going to bust it up the same way, except one stipulation. I'm going to make this less than 10. Nope, not less than or equal. Let's see if this works. I don't know why this is not working. The eraser is not working. There it goes, and then it's too big again. Very strange. Okay. Sorry, technical difficulties. Less than 10. Now, over here, instead of writing less, because remember, we need to make this opposite. I've essentially multiplied by negative 1, which means I need to flip my symbol. So I'm going to subtract 4, I get 2x is less than 6. Divide by 2, x is less than 3. Over here, subtract 4 again, I'm going to get 2x is greater than negative 7. Sorry, negative 6. No, it's negative 7. Negative 14, I'm jumping ahead of, jumping ahead of the game. Negative 14. Then, divide by 2, x is greater than negative 7. There's my negative 7. Now, negative 7 is here, 3 is here. Now remember, they're both going to be open dots. x is less than 3. That's going to be going this way. X is greater than negative 7. It's going to be going this way. So I want the in-between, the overlap. And in interval notation, that's basically just from negative 7 to 3. And they're open dots, so they're both parentheses. Number 11, subtract 9. Get it by itself. 1/3 x minus 6 is greater than or equal to 5. Now I'm going to write it twice. 1/3 x minus 6 greater than or equal to 5. And 1/3 x minus 6 is less than or equal to negative 5, because I effectively multiply the right side by a negative 1. I'm going to add 6 to both sides, which gives me 1/3 x is greater than or equal to 11. And then over here, I'm going to add 6 to both sides, which gives me 1/3 x is less than or equal to 1. Now, how do I get rid of the 1/3? I'm going to multiply by 3 everywhere. So the third cancels, and I get x is, running out of room, greater than or equal to 33. And I get x is less than or equal to 3. So here's my 3, here's my 33. They're both solid dots, or equal to. Less than 3 goes this way, and greater than 33 goes this way. And then as an interval notation, I'm going to write it up here. Negative infinity up to and including 3. Union, because I have 2 of them, 33 up towards positive infinity. That's a comma. There you go. All right. Here, I'm going to divide by negative 3. Now, you got to be careful. I just said I divided by negative 3. So now my absolute value is 4b minus 4 less than, got to be careful, positive 18. Negative divided by negative is positive, but since I divide by negative, this symbol flips. Now I bust it up. 4b minus 4 is less than 18, and 4b minus 4 is greater than or greater than 18. Almost said R of equals. I'm going to add 4 both sides. 4b is less than 22, and 4b is greater than, sorry, I got my negative, didn't I? Silly me. I wrote the same thing. And so negative 18 plus 4 is negative 14. I'm going to have to erase. I have no choice. Let's see if that helps. Negative 14. Good. Now I'm going to divide by 4, and I get b is less than 22 over 4. And b is greater than negative 14 over 4. Which reduces to negative 7 halves and 11 halves. If you put negative 3.5 and negative 5.5 and positive 5.5, that's fine also. It's less than this one, but greater than that one. And so it's in between. And again, there are going to be parentheses for my interval notation, and it goes from negative 7 halves to 11 halves. And again, if you decided to write it as negative 3.5 to 5.5, that is perfectly okie dokie. Number 13, it's ready to go. This is by itself. I'm ready to bust it up right now. 1/2 x minus 3 is less than or equal to 10. And then over here, bust it up a little bit further. 1/2 x minus 3 is greater than or equal to negative 10. I'm going to add 3 and get 1/2 x is less than or equal to 13. Then I'm going to get 1/2 x is greater than or equal to negative 7. Now, how do I get rid of the 1/2? Multiply by 2 everywhere. So x is less than or equal to 26. Sorry about that. And over here, oops, I got my x. I want to get x is greater than or equal to negative 14. So negative 14 is here. 26 we'll put over here. It's solid dots all around. And since it's greater than negative 14, but less than 26, there's my overlap. And again, I'm going to have brackets from negative 14 to 26 inclusive. Almost done with Unit 1. Okay, 14. Solve for the given variable. I'm solving for k. I like to circle it or underline it or something to know what I'm getting. So I want my k's on the one side and everything else on the other side. So I'm going to add 2k. All right? 9k plus 2k is 11k. The 7p is still over here, equal to 18, because this moved. Now I need to get rid of this. So you have 11k is equal to, it doesn't matter, some people write 18 minus 7p, and if you wrote negative 7p plus 18, it's still the right answer. Next, I want to divide by 11 to get my k by itself. That's pretty much my answer. K is equal to either 18 minus 7p over 11 or negative 7p plus 18 over 11. Either answer is perfectly acceptable. 15 is a little tricky. I want my b's on the same side, because that's what I'm solving for, the b's. So I need ab minus cb on the same side. Plus y equals negative x. I need to move the y over. So it's going to give me ab minus cb is equal to negative y minus x. If you put negative x minus y, perfectly okay. Now I want b by itself, so I'm going to do a GCF and pull that b out, factor it out, divide it out, and get a minus c equal to negative y minus x. Now at this point, what's attached to my b? Well, this a minus c, the binomial. If I divide by that, it cancels. So my answer is b is equal to negative y minus x over a minus c. And again, if you did negative x minus y over a minus c, perfectly acceptable. Now let's have some fun with some graphing. Graph the equation. Now, there's 3 ways to do this. The cover-up method. If you cover up the 8y, divide by 6, you get x is equal to negative 8. So where's x-axis of negative 8? Right there. If you instead cover up the x, let's get that back there. So if you cover up the x, you have to divide by 8, which gives you y equals negative 6. Where's the y-axis of negative 6? Right there. And then you just draw your line. That's one way to do it. Okay? Another way to do it is to instead solve for y. 8y is equal to negative 6x, move it over, minus 48, that's a 4 over 4, then divide by 8. That gives you slope-intercept form, negative 3/4 minus 6. And then you go to negative 6, and you go either 1, 2, 3, 1, 2, 3, 4, or you can go up 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, and connect your dots. And the third way is your handy-dandy calculator. Go to y equals and put in, now you have to solve it for y equals form, obviously, but then you can put in negative 3 divided by 4, x minus 6. And if nothing else, this is a nice way to confirm that you graphed it the right way. There's no reason to get a problem like this wrong. Start at 0, look at my table, and there's some nice points I can graph. And I can just look for whole numbers, like so. So even if you do it the other two, one of the first two ways, cover up or solve for y equals, it doesn't hurt to use your calculator to verify. Okay, number 17, again, options. This one works pretty okay for cover-up method because 7 and 14 both go into 56. So if I cover up this, I get negative 7x equals, I need to move the 56 over, right? And then I divide by negative 7, and I get x is equal to positive 8. That's over here, sort of. That's way off. There you go, a little bit better. All right. Then, instead, if I cover up 7x, negative 7x, I have to divide by 14, and that's y is equal to 4. That's up here. Notice again, I have a negative slope. All right. Now again, if I wanted to, since the y was by itself on the right side, sort of, if I divide everything by 14, whoops, that was not supposed to happen. I divide everything by 14, look what I get. Y is equal to negative 1/2 x plus 4. Well, again, what's my y-intercept? 4. And I go down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2, and my line's a little bit off, but you can see how you graph it that way. Again, I'm not going to spend the time, but if you want to, you plug that in your calculator and verify you're drawing it correctly. There's no reason to miss any of these on the calculator. Okay, this is already in slope-intercept form. Here's my M, here's my B. I just can't let it go. There you go. So my starting point is at positive 6. My slope is negative 1 over 4 or 1 over negative 4. Either way, I can go down 1, right 1, 2, 3, 4, down 1, 1, 2, 3, 4, or I can go up 1, 1, 2, 3, 4 left, up 1, 1, 2, 3, 4 left, and I have a very shallow line. Again, another negative slope, but remember, for one thing, if I write my name on it, or you write your name on it, it's going downhill slightly. That's a negative slope. All right? Verify with the calculator, you'll make sure you're going the right direction. Okay, y equals negative 4. That's one of our special lines. Put in the calculator, see what it is, because you might be like, oh, I can't remember. Is it this one, or maybe it's this one? Don't guess. There's no reason to guess. If you're not sure, put it in your calculator. Y equals, clear, negative 4. Bam. Oh, yeah, that's right, it's that one. I did it again. It's negative 4. Horizontal line. But why is it like that? Let's look. Let's go to the table. Y is always negative 4. See right here? Y is always negative 4. X changes. So left, right changes, but Y does not. It's constant. And that's it for Unit 1 review.